Okay, 2.2. So powers of 10 and the exponent 0. So, powers of 10. So if we have an example like this where it's 1,000, this is actually going to be really easy. So 1,000, if I was going to write this just as a power, would be the same thing as 10 to the power of 3. Can you guys see like an easy way of knowing what it's going to be? 10 to the power of 3? Like what's the connection there? Yeah?
Because there's 3 zeros.
It's 3 zeros. That's kind of it. It's going to be 10 to the power of, and then count the zeros. That's what it'll be to the power of, right?
Actually, because I actually did this in the last lesson. It was like at the very end of 2.1.
Yep.
And actually,
yeah. So yeah, that works. Think of it that way. So the next example would be a million. Would be the same thing as 10 to the power of, well, there's 6 zeros, so just 10 to the power of 6. Right? Not too bad, right? Let's think about why that is, though. Like, you can just remember that that's what happens, but really what's going on here, 10 to the power of 3, well, let's write that out again, just doing what we did in the last lesson. 10 to the power of 3 would really be, right, 10 times 10 times 10, 3 times. That would be 10 times 10 times 10, right? So then 10 times 10 would be 100. And 100 times 10 would be, so 100 times 10 would be 1,000. So there's 3 zeros. And you can kind of see that clearly here. There's 1, 2, 3 zeros if you actually like wrote that thing out, right? This only actually works out with 10 to the power of things, right? Just with base 10. Like 20 to the power of something?
Yeah.
Won't work out so nice. If you go like 20 to the power of like 3 or something like that, then you can see pretty quickly that would be the same thing as like 20 times 20 times 20.
400 times 20.
Yeah, so now we're like we're introducing new numbers, right? Because like 20 times 20 is 400 times 20. So it only is going to work out nice and neat like that with base 10 things.
What about like 100 to the power of 3?
100 to the power of 3. It still won't work out nice. It'd like to be the same amount of zeros, because if I had 100 to the power of 3, then that would really be 100 times 100 times 100. And you could count the zeros now. How many zeros would there be? 6. Yeah. So again, it only really works out with base 10, right? Where you can just have the number of zeros. So someone already said it there, and we're going to kind of get into it a little bit below. This actually has applications, and it has applications in science. Does anybody know where this comes up in science? Maybe you've learned it, maybe you haven't, I'm not sure. So yeah, so what do you guys think? So application in science class, maybe you've seen it, maybe you haven't. Some people had their hand up before.
Like 10 squared or 10 cubed?
Have you seen something written like this? Maybe you haven't. If it's like 3.6 times 10 to the 3.
yeah,
That's what you were thinking of, right?
Are you talking about the scientific one where like it's like 3,625,000?
Yeah, you guys were taking space, right? That was the unit you guys were just doing in Science 9. Yeah, those are really big numbers, so quite often you have to write things in scientific notation. So, well, here, I'll get into it below, but like the reason why this is going to be useful for us is we're going to be able to use that to write big numbers out. So I'll wait to get into that though.
Yeah, then thank you.
Okay, so let's go calculate 10 to the power of 8. No calculator, we can just do this in our heads.
Oh, that's easy.
So what would that be? That would be a... Okay, here's the question now. Is it a 10 with 8 more zeros, or is it a 1 with 8 zeros?
10 with 8 zeros.
This is where the people might get confused. Yeah, it's actually a 1. It's a 1 with 8 zeros. It is still a 1 with 8 zeros. In the same way that this one was, right? This was a 1 with 3 zeros, was 10 to the power of 3. Right? So this still will just be a 1, and then just 1, 2, 3, 4, 5, 6, 7, 8. Done. Okay. Now, negative 10 to the power of 2. Are you positive?
Yeah, because it's a negative fraction.
All right, so that is going to be negative 10 times negative 10, really, is what we're doing here, right? So if I go negative times a negative, that's going to be positive, and 10 times 10 is 100, so positive 100. Next one here. So this was from last lesson too, right? Just being careful with these negatives. Okay, so negative 10 to the power of 5.
I got negative 100,000.
So
It's an odd number.
There's no brackets.
it's an odd number, but even if it wasn't, even if it was an even number, look at where the brackets are.
There's no brackets.
This is negative 10 to the power of 5, but really this is like 10 to the power of 5, and that negative is just tacked on the front, right? That negative, that's different than if it would have been written like brackets, like bracket negative 10 to the 5. They'd both be negative, but if that was like 4 or something, then that would come out positive, right? So just be careful with the brackets. Okay, so that would come out as negative, and then a 1, and then how many zeros?
1, 2,
5.
3, 4, 5, 6.
That's it.
Would we have to put like the comma?
All right, so now, so that's powers of 10. Now, what about something to the power of 0?
0.
It's whatever.
Well,
you-
let's.
0.
This is always a weird one. Let's work our way backwards here. So if we said, okay, well, let's start from here. I want to do the whole thing. 10 to the power of 4 was 10,000, right? 1 with 4 zeros. 10 to the power of 3
1,000.
was 1 with 3 zeros. 10 to the power of 2 was a 1 with 2 zeros. 10 to the power of 1 was a 1 with 1 zero. So 10 to the power of 0,
There's 1. It takes away that other.
yeah, is actually just 1.
But hold on. I'm confused. I thought when you have the power, say it would be like 10 to the power of 0. You multiply 10 by 0.
Right. Yeah, so here, let's think about this, because we're not multiplying by 0. We're going to the power of 0.
Oh, so
Right,
you're
that's
multiplying
different.
by- oh, I-
It's like it's multiplying by itself 0 times,
Yeah.
right? And it's a weird one because it just ends up being
I thought it was the
1.
number that was being, like the base. Like it was like it's like 10 or 100 to the power of 0. I thought it'd be like 100.
Oh yeah.
So like,
Yeah. So think about let's remind ourselves what this is, right? Like 10 to the power of 2 was 100, right? Or 10 times 10. It's like 10 times 10 is what another way of writing that. 10 to the power of 1 was just 10 itself. And then you could think about 10 to the power of 0 as like just getting rid of that 10. It's like dividing it by 10 if you want to think about it that way, right? It's like you've got, so 10 to the power of 0 was just the number 1. It's like the 10 is gone. It's like canceled out.
You
So
take away
whenever-
the 0.
It's a strange concept, right? Like I get it that this is always one where people are like, "What? To the power of 0?"
But-
It's one of these first times in math that you guys like. It's not as intuitive as you might like.
But let's say,
Okay, so then the question was, what do we do if you have something else to the power of 0, like 12 to the power of 0?
246.
It's equal to 1. Anything to the power of 0 is 1.
It actually just, that's what all Exponent is. You just like spam 1 in every single one.
Yeah. Okay. So this the formatting on this one turned out kind of funny. I'll write this again. This was like 2 to the power of 0 is equal to 1. Negative 5 to the power of 0 is 1. But before you guys turn the page here, let's write this one out again here. Negative 2 to the power of 0, it's saying that that's negative 1?
yeah, because
Why does that make sense?
because there's no brackets, the negative just stays in front.
The brackets, right? The brackets mattered here. This is just 2 to the power of 0, right? 2 to the power of 0, which is 1. And then that negative is just tacked on the front. So it'll end up being negative 1. Careful with those, because that's where people will make the mistakes on these. All right, let's do these. Calculate 4 to the power of 0.
1.
1. Calculate negative 4 to the power of 0.
1, negative 1.
All right, how many people think 1? How many people think negative 1?
Nope, it's negative 1.
Negative 1.
And I was-
Because, again, right, this is just 4 to the power of 0 is 1, and then that negative is just tacked on the front. So that's just negative 1. All right, what about this one? Negative 4 to the power of 0. 1, because the whole thing is to the power of 0, and anything to the power of 0 is 1. What about this one? What if I had 4x minus, you don't have to write this down, 3 divided by 4 over 7, all to the power of 4, and then all of that to the power of 0.
What? No.
Why?
What's the answer?
Wait, what was X even?
negative one?
I don't even. Well, it's a variable, but I don't even care. What's
Negative
anything to the power of 0?
Well, it's negative one because it's not a bracket around the negative 3.
Yeah, but Ryan.
But you see this like square bracket here?
Coordinated that end up being
The whole thing, like the whole thing, is to the power of 0. So I don't even care what happened on the inside of that. It's all 1.
I like how you could continue that void till it's like as big as it is.
And then
Yeah.
you put a tiny little zero so that you
Yeah.
can see it.
Okay, so
Make them do it.
Keep going.
before I move on there too, I just want to kind of like maybe quickly go through scientific notation to kind of remind you guys of that. Sometimes in math we have really really big numbers, right? And sometimes in science, like in astronomy, like you guys were just doing, or space, you'd have a number like maybe this,
It's just repeating. Keep
right?
going.
And that's a really awkward way to write a big number. Like I don't want to write that down every time. So what we do instead is we would write this as 2, and then it's 2.6. I just put like the decimal right there. And then what you can do is say, okay, how many decimals did this move from there to there? Or you can just like say, okay, the decimal was there, and you move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times.
Yeah, that's what I was.
Yeah, that's what you guys were doing, probably, right? So then that would just be 2.6
I would
times 10 to the power of 9. Right? So that's where this comes in handy, having like, being able to write things out as 10 to the power of something.
Couldn't you just write that as 26 0, like 260 with a line to the right of the 0?
Well,
That would be infinite.
It's not repeated.
We can actually write this out if we want to. I could have written this as 26 and then only move the decimal place over 1, 2, 3, 4, 5, 6, 7, 8, like left or right there. And then this would be 26 times 10 to the 8. It'd be the same thing, right? Because this is really saying 26 times, like, well, this number is just 1 with 8 zeros.
Or 260 times 10 to the 7.
Yeah, you can write it out lots of different ways, but typically in scientific notation, when you guys do this, we write it as a decimal like this. Just one number, decimal, and then the other number.
And it could be like 6 1, so you write all of them until it says 20.
Yeah. Yeah, we don't do too much of this in math this year, but I know in science you guys do that quite a lot, right? So, especially, yeah, you guys will do that more in chemistry as well, I think, this year. So, okay. Order of operations. So we started off with, oh, actually, you know what? I'm going to end that video.